Hey folks, welcome to the first part in this Geometry Nodes driving game series. In this one, we're not actually going to be touching geometry nodes. We're going to be doing something which is going to turn Blender into a viable interactive experience, and that is controller support. So we need to find a way of getting a controller plumbing through into Blender and into geometry nodes in a way that we can then use that data. Now, if you don't have a controller, or if you're not using a Windows PC, then you can still follow along for the second part of this video. The second part of this video is going to be setting up a little sort of screen controller, so it'll be a little joystick we can move inside the camera, and that will have the same control scheme that we'll be using with our controllers. So there will be things later on in the series like switching between different cameras, moving the camera left and right, that we will be sort of setting that up expecting a controller, but you can just follow the same paradigm that we do in this session for adding additional little on-screen UI elements for that control system. For those of us with controllers, let's begin. I have here a completely fresh version of Blender 4.0. This is just to demonstrate how to install the add-on that we are using, and the add-on is this one. This is the Xinput Reader. It uses the Xinput library, which is unfortunately Windows only. I just threw this add-on together. There are definitely other ways of doing this. I've seen people using the inputs library, which is cross-platform, but I couldn't actually get that one working for me. Essentially, what this add-on does is it brings controller inputs into Blender in a way that we can use them with drivers, and it also has a way of setting up drivers automatically to a node group so that we can use it in geometry nodes. So it is specifically designed for people working with geometry nodes. Link down below in the description if you want to grab this as well. You can either just download the whole zip, or you can go to the releases if you want to grab a standard version here. Installation here is super simple. Go ahead up to Edit Preferences, and on your Add-ons tab, we are going to install the Xinput that we just downloaded. Here it is. And if we expand this, we can see that in the Preferences settings, there's a button for installing Xinput. Before we press this, let's go ahead to our window, toggle system console, and there we go. So this is just an important way for us to actually see what scripts are doing in the background. A couple of things before you hit this install input. If you have Blender installed in C program files, you might have a problem with this saying that it doesn't have permissions to do an installation there. In which case you can try right-click, run as administrator, and then see if that works. Or what I tend to do is I actually have Blender not installed in C program files. I just have a portable version outside that. And I generally find that gives me all of the permissions that I need for any kind of installation. So in this case, let's have a try at clicking this install Xinput. And we're going to keep up our system console here, and we can see that it is already satisfied for pip. So that's all updated as it wants to be. And then it's now collected Xinput, installed it, and it's saying it's successfully installed. So now we can go back into here. And we may need to restart this after installing, but let's just have a check. We should see that we have the Xinput tab, and I can hit that button and it's immediately thrown me an error. So what I'm going to do is I'm going to close my Blender session, and I'm going to reopen Blender here. And this time, if I go to Xinput, you should be able to monitor this controller. You can see that we've got all of our controller inputs listed down in this panel. And that button at the top says right click or escape to stop, so I can press that and you can see we swap back. So this isn't a toggle button, it's just a trigger, and it's running a modal. So a modal is an ongoing operator that is going to be constantly active. So when we have monitor controller on, you can see when I press a button, such as the A button, our controller inputs is now turning that Boolean on for A, B, X, Y. When I do a joystick, you can see that we have our right thumb, X and Y separated. And for our triggers as well that we're going to be using for acceleration and braking, you can see that we have those there. Buttons are just a Boolean. Anything with a continuous input is coming in as a float there. So the other part of this add-on is the drive node group. So let's just bring up a geometry nodes editor here. Let's create a new geometry nodes just on this cube. And I'm going to click drive node group. Now, if I add the group Xinput Reader, you can see in here that we have all of this set up with drivers. Let's go back. If I just add something simple like a geometry transform node, and let's plug let's just plug the right trigger into the scale here. I can now set the scale of my cube based on that trigger input. So super fun. You can have a lot of fun with this as soon as you have this set up. The world of interactive geometry nodes is open to you. So I don't even need to be running an animation for this to be working. We will do later once we're working with simulation nodes, but for now, you can see this is working just on a single frame. If you're using simulation nodes and you record a session while caching the simulation nodes, then you can actually go back and replay that without then using the controller input. So it's a fun way of actually recording things. You can set this up to auto keyframe. You can do all sorts of things if you want to have a really good play with interactive geometry nodes. So what if you don't have a Windows PC in order to use the Xinput Reader add-on, or you don't have a controller, in which case you can't use a controller? Well, we do have an option here for using a sort of in-camera UI to give ourselves the same kinds of controls that we'll be using with the controller. So let's go ahead and set that up. First things first, let's make our scene where we want it to be for our camera and UI elements. So let's go into our scene collection up here. We have this main collection. Let's make a new collection, call it camera. And we're going to be just dropping in our camera straight into this one. Now let's disable our other collection that has our light and cube in it. And for now, let's just add a plane down here. And this is just a default sized plane. Let's go into 7 for top down view. We're going to tab into edit mode, press I to inset, and we're just going to make a decent little border around here. Something like that will be fine. And then you can delete that internal face. Let's rename this object to joystick bounds. Then go ahead and add a new mesh icosphere. Scale this down. Something like this should be fine. And rename this item to joystick. Now, we can move this, but we can move it anywhere. And we can also move it in the Z-axis. So we don't necessarily want it to behave in that way. First things first, let's just parent it to our bounds. So select our joystick bounds, Control P, and then object like so. Now I can move the bounds and I can scale the bounds, and our joystick element still has its original transforms. Next thing is going to be constraining the joystick. On the right hand side on our panel here, let's go down to the constraints icon, which is this double pulley, add an object constraint, and we're going to be limiting the location. We're interested in setting a minimum XYZ and a maximum XYZ, where we want X minimum to be -1, -1 for Y, 0 for Z. And then in the maximum, we want 1, 1, 0. Press N to bring up your sidebar here. And you can see that as we move this around, we can no longer move it in the Z-axis. We can only move it in the horizontal axes. But even though it has stopped moving, we can see that our location up here is still -2.8. And it shouldn't be able to be outside this one area, 1 meter square bounds, because then I get this issue where I'm moving it, but it's really around here. We're not actually moving the object that we want. So we also, on our constraint, want to hit Effect Transform. So now you can see that we can only move it up to that -1 to 1 space. Now, what happens if I move my bounds? Well, now we have an issue where our constraint is preventing it from following the bounds object. So let's just Alt-R, Alt-G to put that back. We then want the owner on our constraint, on our joystick, not to be world space, but to be local space. You could even set a custom space if you wanted it to be specifically belonging to the joystick bounds, but the parenting has sorted this out for us. So now I can move this around, I can rotate it, and my joystick is still just going to be limited to sit within that frame. So now we have joystick controls, which follow our bounds object. Now we want this to sit inside our camera, so we're also going to take our joystick bounds and we're going to put it underneath our camera. But first, let's take our camera, press Alt-R to rotate it back to 0 rotation, Alt-G to put it back to 0 location. And then what we're going to do, with the camera at the origin is we're then going to position the joystick bounds and scale it to fit where we want on our camera. So nice and easy, just put it down below the camera, scale it to somewhere in this bottom left corner. That's where I'm going to put mine. Then we just need to make sure that we have taken our joystick bounds, shift click on the camera, Control P, parent object. So now as I move around, we have our own little joystick sat in the corner here. And as I move this around, we can see that its actual location goes all the way to -1, +1, even though it's all scaled, even though it's all small, because we've done that little bit of parenting and local space constraining. So there we go. We can press Alt-G and it will go back to its own local 0, 0 position. So Alt-G is always going to reset your joystick. Fantastic. All right, we have a little UI element here. Let's make sure that we've set some materials on this, because if I go into material preview, I don't want this to all be shaded. I want it to always draw over the environment. So let's go into our material options. Let's go for joystick bounds, create a new material, which we're going to call UI. We're going to replace the surface with an emission, and we're just going to set this to whatever color we want. So you could go for something like a red, and then it's just going to show up red. Same for the joystick. Let's add that UI material. And now we know this is a shadeless material, so it's not going to be affected by lighting information. And even if we're in the dark, it's going to draw on top. Fantastic. So we have a joystick. Does it control anything? No. So let's set up our control system for how we want this to interact with our steering angle, our acceleration, our braking and reversing. Let's turn back on our collection, which contains the cube. And we can just sit in our geometry nodes here. Let's set this up. So we're going to be setting up a node group for our control system. So let's start off with a couple of value nodes, and we're going to use these driven by our joystick position. Let's go back to our cube. I'm actually just going to pin this node tree right now. Press N in my viewport. I'm going to select my joystick object specifically. And let's right click on the location X, copy as new driver. And we're going to paste the driver into this value node. Press F2. This value node is going to be called joystick X. We're going to do the same thing with the Y axis. So let's select the Y here, right click, copy as new driver, and paste this into our other value node, which we will call joystick Y. So now, as I move these around, you can see that those value nodes are changing accordingly. Awesome. Select both of your value nodes, Control G to put them into a new group. Tab back out. This group is going to be called _controls. Tab in here. And we need a few things. All right, so our joystick, let's just plug this straight into our group output. And looking in our group interface here, we have a new value output, which we're going to be called steering angle. Now, rather than it just going from 0 to 1, we want this in radians. So we want to know how far we're actually going to be steering. So instead of 0 to 1, we might want this to be 0 to 90 degrees, but we can't just multiply by 90 because it's in radians. So let's go ahead and grab a utility math node, set this to multiply. And then we need another math node, which is going to be 2 radians. And then we can set a degrees angle in here for what we want our maximum steering to be. For example, I might say, I want this to go up to 60 degrees. Now, in our main node tree here, let's just debug this a little bit. So let's plug this into a control XYZ. We're going to plug it into the Z axis, that steering angle of this rotation. And now you can see that as I rotate this, our cube rotates one way and other. So that's fun. We've already got a little bit of a steering behavior going on here. Okay, next thing then. Let's go back in. We also want to know when we are accelerating, braking, or when we are reversing. And when we are using a controller, this is a little bit easier because we have specific buttons. For example, we have our accelerator on that right trigger, our brake on the left trigger, and reverse is going to be B. When we're using this joystick interaction, we have something a little bit different. So when the joystick is forwards in the positive Y space, it's going to be accelerating. When it's at 0, 0, we are going to be applying the brakes. And when it's going backwards, we're going to be telling it to accelerate in reverse. So we just want this to be as close as possible to the setup that we'll be using for the controllers, just to make this easier for everybody to follow along together without needing to make any adjustments on the fly. So let's take our Y-axis of our joystick. And first of all, I want to know the acceleration force. So I will be accelerating forwards or I will be accelerating backwards, but both of these are essentially the same. So just interested in the magnitude of this, whether it's between 0 and 1 forwards or 0 and 1 backwards. To find this, we can use another math node set to absolute. Plug this in. And this is going to be then a 0 to 1 value without any positive or negative sign. Now, I also want to add another multiplier in front of this, just in case I need to set it to be higher or lower, depending on how our acceleration is affecting our truck as we build through this exercise. And this is going to come up to our group output as well. Let's rename this one Accelerator. The next one that we want to know is whether or not we are braking. So this is just going to be whether or not our joystick is in the middle here. Have a Y value of 0. So let's use a compare node. Let's take our joystick value, pull off a compare, and we're interested in when it is equal to 0 with a small epsilon. This can just be plugged in directly into our group output, and this one will be called braking. I will set this to be a float just to match our controller version. Now the last one is whether or not we're going to be reversing, and this is simply a yes, no, just the same as if we were pressing a button on the controller for whether or not the joystick is moving forwards or backwards. So if it's backwards, then the sign will be negative, and if it's forwards, the sign will be positive. So what I'm interested in here really is just comparing whether the joystick Y is less than 0. So if it is less than 0, then we are reversing. And if it is not less than 0, then we are not reversing. If it's greater than 0, we're going forwards. So there we go. We've got this Boolean coming through, and this one can just be set to reverse. And there we go. Now, if we want to see this on the cube, just to debug what's going on really quickly here, let's set this up nicely. So what we can do is just set our accelerator into the translation. And then as we move it forwards, you can see that it's always coming into that positive X space. And we can set braking into the Z. So it's going to go forwards. And then anytime we go to 0 again, which you can do with Alt-G to reset that joystick position, we can see we're going to go up. And then if we're reversing, let's put that into the Y scale as well. So there we go. Now we can see that these are all working. We have our steering, acceleration, braking, and reversing. Fantastic. So these are the controls for the on-screen UI if you are not using a controller. Let's just return very quickly to people who are using controllers. If you are using a controller, then you're going to want to also set up your control input similarly to this. So let's just modify this group so that if we are using a controller, it's going to work for us as well. So in here, rather than using our joystick X and joystick Y in this same way, we're going to make sure that we have a node group available by clicking Drive Node Group, just in case you haven't created one yet. Going to go ahead and add that group Input Reader inside our underscore controls group, and our steering is going to be the left joystick. So let's have a look at this. We are looking at left thumb X as our input for that steering. And I can always hide, right click, show hide node options. Let's just compact that node, duplicate it, unhide. Now we're looking for the accelerator. So the accelerator for a control input is going to be the right trigger, the right shoulder trigger there. So let's go ahead, find that right trigger. Again, this is 0 to 1 value. We can just plug this straight into the multiply. So we're not interested in doing an absolute. We are just reading the 0 to 1 value from that trigger. For braking, we are going to be using the left trigger. We'll just plug this into braking for now. We'll sort out the specifics of it later. And for reversing, we're just going to be using the B button. And I can get rid of that less than. And here we go. So now I have the same setup essentially, but I might even make this a little bit more individual, just so that I have each section as its own thing. So that's how we do it. We do our left thumb X as our steering angle, going multiplied by the radian value there, coming into the steering angle. We have our right trigger almost directly. We'll just use this multiply because we have it into the accelerator. Left trigger directly for braking and B button directly for reverse. And that is going to give us all that we want on there. Now, one final thing, if you do want to play around with this, it can be nice to actually keep this UI element, even if you're using a controller, not as a controller, but just to check that the controller inputs are moving things around. So what we can do is set up a bit of a driver system to our joystick object, to its positions based on the evaluated controller inputs. So let's see how we can do this. Let's grab our joystick and have a look at this object properties page, and we can set the transforms in here. For location X, we just want to use the left thumb X. So right click on this, copy as new driver, paste into left thumb X, paste driver, there we go. Now, the Y axis is a little bit more complicated, but we're just going to put together a little driver for this as well. So go ahead, and for now, we're just going to take the right trigger, copy as new driver, paste into that Y value. And you can now see that if I monitor my controller, I have my left thumbstick controlling the X axis, and I have my right trigger controlling the Y axis. We need this to be a bit more complicated because we want it to know if we're reversing. So right click on this. We're going to open the driver editor just so that we have another window for this. And let's come in here and just expand this. We're not doing an averaged value. We're going to be doing a scripted expression. We're going to add another input variable, which is going to be called rev for reverse. And the prop is going to be the Xinput Reader. And the path here is just going to be square bracket, speech marks, B, speech marks, square brackets, just like that. And now we have the same kind of layout as we have before. And this is just going to be the B button press. The expression is going to be right trigger if not rev, else negative right trigger. Okay, so we're basically saying use the right trigger if rev is not true. So if rev is 0, then we're going to use the right trigger, and if rev is 1, then we're going to use the inverse of the right trigger. So right trigger if not rev, else negative right trigger. So it's just a little Python expression into that driver. Now if I monitor the controls, you can see as I press that trigger, we go forwards. And if I hold B while I press the trigger, then we go backwards. So there you go. Nice little bit of trigger action with that driver, and that's all working perfectly. We now have a control system working and debugging if you're using controllers, and as well if you're using a screen version, then that is all going to be plumbed through, and we can now continue with the actual building of the game. So at this point, once you have a controller set up, you can do almost anything with geometry nodes, and you can make it really interactive and really fun. So if you're doing installations, you can use a controller, or you can even set up other kind of MIDI inputs and just use Python to interpret those inputs, bring it into geometry nodes, set up drivers however you want, and it's all going to work perfectly for you to set up really interesting, interactive geometry nodes experiences. That's it for this one. Join me in the next session where we're going to be building the chassis for our trucks. I'll see you there.